In this section we're going to look at first order linear differential equations, and this is an equation of the form shown below: dy dx plus some function of x p of x times y equals another function of x q of x. And the above form of the equation is called the standard form of the equation. In the standard form you see that the coefficient of dy dx is 1 and the coefficient of y is a function of x, which we're going to call p of x throughout. Now, sometimes we're given an equation which is not in standard form, and the first thing to master is putting this equation in standard form if that's possible. So for this equation in this example, we have x times dy dx is x squared plus 3y. And we'd like to put that in standard form. It's a first order linear differential equation, and we need to divide across by x so that the coefficient of dy dx is 1, and then we need to bring the y term over to the left. So we have dy dx minus 3 over x times y is x, and now this is the standard form of the differential equation. Now there's a standard method to solve these first order linear differential equations. First, we put the equation in standard form: dy dx plus p of x times y is equal to q of x, and then we multiply the equation by a function of x which is called an integrating factor. And that function we're going to call I of x, and it's equal to e to the power of the integral of p of x dx. Now, the reason for creating such a complicated looking function will become obvious when you see what it does. This function I of x, the integrating factor, has the property that its derivative is p of x times I of x. And you can see that if you differentiate the function, you get e to the power of the integral of px dx times the derivative of the integral of p of x dx, which is p of x. Now, multiplying the differential equation across by this integrating factor, we get an equation of the form I of x times y prime plus I of x times p of x times y equals I of x times q of x. Now notice what's happening on the left-hand side. I have the integrating factor I of x times y prime plus the derivative of the integrating factor times y. And that should remind you of a rule of differentiation that we studied in Calc 1. The left side of the equation is the derivative of the product ix times y. So we can rewrite the entire equation as the derivative of ix times y dx equals ix times qx. And now we can actually solve the equation as long as we can integrate the right-hand side. So integrating both sides of the equation, I get the integral of the derivative of the product ix times y is equal to the integral of the right-hand side, which is the integral of ix times qx dx. And of course the integral of the derivative is the function itself, because these two operations are inverses of each other. So on the left-hand side, that whole mess boils down to ix times y plus c, and on the right-hand side we get the integral of ix times qx dx. Bringing the c across and dividing across by ix, we've solved for y. Y is the integral of ix times qx dx plus c over ix. Now, rather than remembering that formula, you should remember how to carry out this process, how to find the integrating factor and how to solve the equation. So let's try to solve this differential equation. X dy dx equals x squared plus 3y. The first step is to put it in standard form, And we've already done that. We get dy dx minus 3 over xy equals x. The next step is to calculate this integrating factor. That's ix equals e to the power of the integral of px dx, where px is the coefficient of the y term. So ix is e to the power of the integral of minus 3 over x dx, and of course the integral of 1 over x is the natural log of x, so that's e to the minus 3 times the natural log of x. And we know that e and the natural log are inverses of each other, so that boils down to x to the minus 3 or 1 over x cubed. Well, now once we've calculated this integrating factor, the next step is to multiply our standard equation by the integrating factor. So multiplying across by x to the minus 3, we get x to the minus 3 dy dx minus 3 over x to the 4y equals x to the minus 2. And this left-hand side should always be the derivative of y times the integrating factor. So you should check that just to make sure that you've calculated this integrating factor properly. But the important thing is that it's the derivative of y times x to the minus 3. On the right-hand side, of course, is x to the minus 2. The next step is to integrate both sides of that equation. So the integral of the derivative of y times x to the minus 3 is the integral of x to the minus 2, which is x to the minus 1 plus a constant. And of course, the integral of a derivative of a function of x is going to be that function itself plus a constant. So the left-hand side is x to the minus 3y, which is equal to x inverse plus c. And now solving for y by multiplying across by x cubed here, we have y equals minus x squared plus some constant times x cubed.